All right, so now when we rotate that rectangle, it's not going to make a disc anymore. It's going to make a washer. So what we need is to find the area of this washer. So if you think about it, what we really have here is a big disc, which would have an area of pi capital R squared, and we're taking away the little one. So we're basically punching a hole in it. So by punching in a hole, we're just going to subtract it. So putting this together, we end up with pi big R squared minus little r squared. So now we're going to have two radiuses when we graph these. Okay, so let's try one. So we're going to find the volume of the solid formed by revolving the region bounded by these two from 0 to 2. So like this. So if we start by drawing our rectangle, and again, we are rotating this about the x-axis. So just like with the disc, if we rotate about the x, we want to make sure that we do a vertical. That will now give us y equals for our graph. So let's look at how this looks with Desmos. So now if we rotate it, we get this. So if you move it a little bit, there's a major delay going on. We end up with this. You can see it's a washer. And so the top function is the bigger one, and the function is the smaller. So if I move it back, you can see that that's our y equals 2x is the top, x squared is the bottom. So that's the rectangle that's being rotated. And so you can see y equals 2x is our top radius, and y equals x squared is our bottom radius. So if we take this picture that we have over here, because these are not actually the same functions, and do our little graph, going from 0 to 2. And again, we know that's our point of intersection because if we set them equal to each other, we get x equals 0 and x equals 2. So those are our points of intersection. That's what we're rotating, is this object. So now if I draw my rectangle within there, and I rotate it, and always rotate it just like at an angle, as if you're looking at that picture from Desmos, so that you can get your disk out of it. And then we go back and we label it, and so this is a dx, and this is a y equals. So we go back up and make sure everything is solved for y, and it's perfect. And so our top function here, the one that makes the top, see how it's connecting right here, that's y equals 2x. And the one that connects at the bottom, that's y equals x squared. So you can see the top one, which is the big R, is 2x, and the bottom one is little r. So if we draw our disk, and then we label it, so that would be big R, which is equal to 2x. And we'll do this one in blue. That would be little r, which is x squared. You can now get our formula. So our area here is pi big R squared minus little r squared. So it's pi 2x squared minus x squared squared. And so if we do a quick little simplify, we get pi 4x squared minus x to the fourth. So that's our area of our disk, which would then be pi 4x squared minus x to the fourth, with a thickness of dx. See, we have it down here. And we're going to add up all these disks from 0 to 2. So it looks like this visually. You can see that the big radius would be our 2x. The little radius would be the x squared. And so that would give us our washer if we subtract them. And then when we take our integral from 0 to 2, it adds up all of those washers. See all the washers being formed as it goes through each one. So like if I were to plug in 1, it would give me the area of that washer, and it's super, super thin. And then so on, plugging in 1.1 all the way to 2. So So that's our integral. So now if we plug that in our calculator, get our answer. And so remember, we want to find exact answers here. So when you do that, you always want to make sure the pi is out because it's our constant from 0 to 2. And then this will give us our volume. So this right here is our work for our volume. So plugging it in our calculator, 4x squared minus x to the fourth, we get 64 over 15 pi. And if you want the approximate, all you have to do is plug that in. So again, we're just making a washer. Let's try it again. So now we're going to find the volume of the solid formed by revolving the region bounded by this and this about the x-axis. So again, we're using washers. So around the x-axis, we draw our rectangle. And we verify that that rectangle does flow perfectly through the entire thing. And we need our points of intersection. But first, we need to label it as y equals and dx to make sure everything is correct. So yes, we have y equals 1 and y equals x squared plus 5. Negative x squared plus 5. So if we set those equal to each other, minus 1, factor out the negative, and you're going to get x minus 2x plus 2, which is x equals 2 and negative 2. Now you can see that we have symmetry here because it is a parabola. So we could just go from 0 to 2 and double it. It's your choice. So we can go from negative 2 to 2, or from 0 to 2 and double it. We could even do negative 2 to 0 and then double it. But our rectangle does flow perfectly through the entire thing. Okay, so here it is in Desmos, and you can see that rectangle fits perfectly. It's always the same two subtractions. So it's the top minus the bottom all the way through the entire function. And then it makes the best shape ever, my favorite food. It makes a donut when you rotate it. And so there's our disk. And so again, going from negative 2 all the way to 2 will form our shape, which is our donut. So going back, you can see there's our disk. And so the top of our disk is our function, which is the parabola, and the bottom is the y equals 1. And you don't need a fancy Desmos graph to figure this out. All you have to do is actually rotate it. And as you rotate it, it forms our disk that we need. And then all we have to do is label it. So the top of it, everything has to be y equals. That's perfect. The top is our negative x squared plus 5. And their bottom is the 1. And so it literally is y equals 1 that we're writing. So our big R here is going to be negative x squared plus 5, and our little r would be 1. That's our little radius. So see that right there is our little r. So little r equals 1. And our big radius here goes all the way up to there, so that would be capital R. So now when we plug it in our little formula, our area is pi big R squared minus little r squared. We end up with pi negative x squared plus 5 squared, put a bracket now, minus 1 squared, and there we have it. So I don't want to multiply that out. You can if you want. I'm going to leave it as negative x squared plus 5 squared for now, but that is a minus 1. And if you want to multiply it out, we can. Oh, let's just do it. Pi, and we get x to the fourth minus 10x squared plus 25 minus 1. So that's pi x to the fourth plus 24. All right, so now all we have to do is create our formula. So again, we're going to go from negative 2 to 2 as it moves through the entire thing, with our area being x squared minus 10x. This is x to the fourth. Copied it wrong. Minus 10x squared plus 24 dx. And again, you can also plug in the unsimplified form. Again, I just want you to be good at setting these up, not making errors. So I want you to plug in what you get to make sure everything is correct. So both of these would be fine. They will both give us the same answer. And again, the thickness of our washer here is dx. So you can see in the calculator that either the simplified form or the unsimplified form are giving you the same answer, which is 832 over 15. So 832 over 15 pi. And there you have it. So all we're doing now is making a washer. So if you have two functions, when you rotate it, if it gives you 2 radii, you know you're using washers.